Hello everyone, welcome to chemistry classes. So in the previous class we have discussed about Nernst equation and also we have solved a problem on Nernst equation. So the problems like that comes every year for your board examination. So please do concentrate on those problems. And today our concept is equilibrium constant from Nernst equation. So in your previous year, in your first PUC, I hope you have learned about equilibrium constant. For every chemical reaction there exists equilibrium. So in those equilibrium reactions we can give equilibrium constant. We have to calculate equilibrium constant. So now today we will discuss about the equilibrium constant, the calculation of equilibrium constant of a equilibrium reaction from Nernst equation. For a reversible reaction there exists equilibrium. For that equilibrium there exists a equilibrium constant. So that equilibrium constant can be calculated from Nernst equation. So now we are going to calculate equilibrium constant by using our Nernst equation. Okay, so for that we'll study about how to calculate equilibrium constant of a reversible reaction from Nernst equation. So let us consider our Daniell cell. The best galvanic cell as we have studied is Daniell cell. So let us consider Daniell cell. So this is my Daniell cell. It is made up of, it is a combination of two half cells. The first one is oxidation half cell. This anode is oxidation half cell. Anodic cell is also called as oxidation half cell because here oxidation reaction takes place. And this is that cathodic cell is called as reduction half cell because here reduction reaction takes place. So we will call it as reduction half cell. So it is oxidation half cell. Here oxidation reaction takes place. Here reduction reaction takes place. Here zinc rod is dipped in zinc sulfate solution. At cathode copper rod is dipped in copper sulfate solution. This is called as copper electrode. This is called as zinc electrode. These two are externally connected by electric wire, conducting wire, and these two are internally connected by salt bridge. They are internally connected by using salt bridge. So here I have inserted a voltmeter to measure the potential difference or voltage in the cell. As soon as key is placed, what happens if I place the key? Means the circuit is completed. If the circuit is completed, the reaction gets starts. Here the chemical reaction in the cell gets starts. So as soon as key is placed, the chemical reaction takes place in the Daniell cell. So which chemical reaction takes place? Here the chemical reaction takes place in the Daniell cell is nothing but zinc plus Cu2 plus gives Zn2 plus Cu. So this chemical reaction takes place in the Daniell cell. So here this chemical reaction means what? Zinc is oxidized, copper is reduced. Here in the oxidation half cell, zinc is oxidized and reduction half cell, copper is reduced. Here zinc is oxidized means what? So here at anode my chemical reaction is zinc is converted into Zn2 plus 2 electrons. Means what? The zinc atoms present on the zinc electrode, they come into solution. Here the zinc atoms have more tendency to become zinc ions. So as key is placed, the circuit is switched on. Here the oxidation reaction starts. The oxidation reaction start means what? The zinc rod is gradually dissolved. Means the zinc atoms on the zinc rod are go into the solution. The zinc rod is gradually dissolved. Means the concentration of Zn2 plus ion in the solution goes on increasing. Here the concentration of Zn2 plus ion goes on increasing in the solution because the more number of zinc atoms are converted into zinc ions. Means they should come into solution. As the atoms are converted into ions and they come into the solution, the concentration of Zn2 plus ion increases in the solution. Here what happens on cathode? Here which reaction takes place? On cathode reduction reaction takes place. Reduction means what? Cu2 plus Cu2 plus 2 electrons gives Cu. Here the reduction reaction takes place. Reduction reaction means what? Cu2 plus ions present in the solution, they come into the electrode. The solution Cu2 plus ions present in the solution, they come near to the electrode or copper strip. They get 2 electrons from the copper strip and they are reduced. Means copper ions are converted into copper atoms. As copper ions are converted into copper atoms, they deposited on the copper electrode. They deposited on the copper electrode. So now what happens? What about concentration of Cu2 plus ion in the solution? More number of ions are converted into atoms. So means the concentration of Cu2 plus goes on decreasing. The concentration of Zn2 plus goes on increasing. The concentration of Cu2 plus goes on decreasing. Here, as the reaction continues, the concentration of Cu2 plus ion in the solution goes on decreasing. The concentration of Zn2 plus ion in the solution goes on increasing. Then what about the potential difference or voltage read in the voltmeter? What happens to that? In our Nernst equation, we know that or we concluded that the E cell value, E cell means electrode potential of cell is varies with respect to copper ions, concentration of copper ions and concentration of zinc ions. As the concentration of copper ion increases, potential cell potential also increases. As the concentration of Zn2 plus ion increases, the cell potential decreases. Now what is happening here? The concentration of Zn2 plus ion goes on increasing. The concentration of Cu2 plus ion goes on decreasing. Means my cell potential also goes on decreasing. The potential difference or voltage measured in this voltmeter goes on decreasing. So after some time, after 1 hour or after 2 hours, what happens? A situation is reached. A situation is reached. In that situation, what happens? The concentration of Zn2 plus ion is constant. Now the no more zinc atoms are converted into zinc ions, means the concentration of zinc ions remains constant, means the oxidation reaction stop. Here at the same time, here the conversion of copper ions into copper atom also stopped, means the concentration of copper to plus ion also stopped, so remains constant. At this condition, as concentration of zinc 2 plus ion is also constant and the concentration of Cu2 plus ion is also constant, this condition is said to be equilibrium. Means in the system equilibrium has been attained. Now in our system equilibrium has been attained. At this equilibrium, what happens to voltage? When there is no conversion of ions, or means there is no transfer of electrons. If there is no transfer of electron, there will be no potential difference. Means in that situation, the voltage read in the voltmeter becomes equals to 0. So here at equilibrium, concentration of Zn2 plus ion remains constant and the concentration of copper 2 plus ion also becomes constant. At this condition, equilibrium is attained. Equilibrium has been attained. At equilibrium, there is no passage of electrons. There is no transfer of electrons in the system. As a result, the voltage read in the voltmeter becomes equal to 0. At that condition, the voltage is equals to 0. So now we'll calculate Nernst equation at this situation. Now we have to calculate Nernst equation for this system at this situation. Which situation? At equilibrium. So now we'll calculate at equilibrium. At equilibrium, Nernst equation can be written as. So what is our Nernst equation? First let us write Nernst equation. E cell is equals to E naught cell minus RT divided by NF ln concentration of Zn2 plus divided by concentration of copper 2 plus ions. So at equilibrium what happens? We know that at equilibrium, when the system attains equilibrium, at equilibrium, what happened? What about potential? At equilibrium, the cell potential becomes equals to 0. There is no potential difference in the cell. Voltmeter do not show any deflection, so that remains constant, that is equal to 0. There is no deflection in the voltmeter, that shows 0 deflection, means that shows 0 reading. Then what about concentration of Zn2 plus and copper 2 plus ion at equilibrium? Do you remember equilibrium constant? We have got two type of equilibrium constant. Equilibrium constant for the solution or equilibrium constant for the gases. For equilibrium constant for the solution, how to write? Let us write equilibrium constant for this reaction. So now, how to write equilibrium constant? According to law of chemical equilibrium, the concentration of product divided by concentration of reactant. Concentration of product here, this is solid is neglected. We have to consider concentration of this aqueous solution, Zn2 plus divided by reactant side, we have to consider only copper. Here zinc is solid, so concentration of Cu2 plus ions. Now Kc is equals to concentration of Zn2 plus ion divided by Cu2 plus ion. What is Kc? Where Kc is called as equilibrium constant. Kc is my equilibrium constant. So let us put the values of E cell and Kc in this equation. Let's see what happens. E cell means what? E cell is equals to 0. 0 is equals to E naught cell minus, I'll convert ln into log. What happens? 2.303 RT divided by NF log of Zn2 plus bar C is equals to what? Kc. Log of Kc. So let us more simplify this. We can write E naught cell is equals to 2.303 RT divided by NF log of Kc. Log of Kc. So at equilibrium, this is our Nernst equation. If a solution attains equilibrium, we have to write Nernst equation like this. So here E naught cell is equals to 2.303 RT divided by NF log of Kc. And now, so let us consider a particular case at 298 Kelvin temperature. At temperature is equal to 298 Kelvin. We know that the standard equilibrium, the standard cell potential of Daniell cell is equal to how much? At 298 Kelvin, E naught cell for Daniell cell is equal to 1.1 volt. Isn't it? We know that at 298 Kelvin temperature, the standard cell potential or the standard cell potential of Daniell cell is 1.1 volt. Now let us put this value in this equation. E naught cell is equals to 1.1 volt. So now it is 1.1 volt is equals to 2.303 RT divided by NF log of Kc. Log of Kc. And also we know that this entire term, excluding this n, the value of entire term is equals to how much? 1.1 volt is equals to 0.059 divided by n is equals to, for Daniell cell, n is equals to 2 log of Kc. Log of Kc. Now what we have to calculate? Equilibrium constant. Now we want to calculate only equilibrium constant. So this is our equilibrium constant. So for this I will take log of Kc is equals to, what happens? Log of Kc is equals to, this 2 becomes this side, 1.1 volt into 2 divided by, this comes here 0.059. Here the log of Kc is equals to, log of Kc is equals to, this value is found to be 37.288. This is found to be 37.288. What we want only equilibrium constant. Equilibrium constant is only Kc, but it is logarithmic value. Now we have to calculate only the value of Kc. Kc is equals to what happens? If log comes this side, what happens? It becomes anti-log. The log comes in this side, it becomes anti-log. Now we have to calculate anti-log of 37.288. 37.288. See here, to calculate log of this number, I will give a simple trick. Kc is equals to, for anti-log of positive numbers, for the anti-log of positive numbers, the number or the places before decimal point, the numbers before decimal points are taken to be 10 to the power. They should be written as 10 to the power. In the answer, our answer must come in terms of 10 to the power 37. Here, what are the numbers are there before the decimal point, they should be written as 10 to the power. However, it may be 1000. So if it is 1000.288, we have to take 10 to the power 1000 only, isn't it? So now we have to take the anti-log of 288. The anti-log of 288 means what? The anti-log of 28th row, 8th column. The log of, anti-log of 28th row, 8th column. So now, where is my log table? See here. Now I read the log. So anti-log of 0.28. How many column? How much column? 8th column. 0.28 1941. It is bound to be 281941. So now it is 1941. Now we have to put a decimal point after one number. So this is my answer. This is the equilibrium constant for the chemical reaction. 1.94 and 1 into 10 to the power 37. So roughly we can write Kc is equals to 2 into 10 to the power 37, isn't it? So I have round off to this figure. 1.9 is nothing but 2 into 10 to the power 37. So this is the value of equilibrium constant for the given reaction. So now let us solve a problem on this. I hope all of you understood this. Now we will solve a problem on this. Calculate equilibrium constant of the reaction. Equilibrium constant of the reaction. Equilibrium constant of the reaction. They have given the chemical reaction Cu plus 2Az plus the aqueous form gives Cu2 plus 2Az. They have given for this E0 cell is equals to 0.46 volt. So now we will solve this problem. See what they have given. They have given everything. Calculate the equilibrium constant of the reaction. We have to calculate equilibrium constant Kc of the reaction. For this reaction, Cu plus 2Az plus gives Cu2 plus to AC. E naught cell is equals to 0.46 volt. So now just directly let us write the solution. So what is our chemical formula to calculate equilibrium constant by using Nernst equation? That is E naught cell is equals to 2.303 RT divided by NF, RT by NF log of Kc. For this reaction, see here how many electrons are transferred? Cu is converted into Cu2 plus, and 2 plus 1 is converted into 0, means 2 electrons are transferred in the chemical reaction. And also they have given E naught cell value. E naught cell is equals to 0.46 volt is equals to 2.303 RT divided by 2F log of Kc. 0.46 volt. So it is same as that of Daniel cell because it is equal to 2. Now we'll write 0.059 divided by 2 log of Kc. Now we want log of Kc. The value of log of Kc is equals to 0.46 volt into 2 divided by, this comes this side, 0.059. Now this value is found to be log of Kc is equals to 15.6. The value is 15.6. Now we have to calculate the value of Kc. Kc is equals to anti-log of 15.6. So it is same as that of previous problem or previous derivation. So now anti-log of 15.6. How to calculate anti-log of 15.6? Now see here, Kc is equals to whatever the answer comes. After that answer, what we have to write? The number present before the decimal point is taken as 10 to the power 15. 10 to the power 15. So this method is followed for the anti-log of positive numbers. Anti-log of positive numbers. Now we have to see the anti-log of 0.6. 0.6 means 0.60. 0.6 means it doesn't mean that 0.06. It is 0.60. 0.60 it is 3981. It is 3981. So now what we have to do? We have to place a decimal point after one number. So it is 3.981 into 10 to the power 15. So this is the value of equilibrium constant. This is the value of equilibrium constant for this reaction. Okay. So now let us. Now I'll give a homework. All of you have to solve the homework. So the homework is calculate the equilibrium constant. Calculate the equilibrium constant for the reaction. Equilibrium constant for the reaction. See my reaction. 2Fe3 plus 2I minus. This is the equilibrium reaction. Gives 2Fe2 plus I2. They have given if E naught cell is equals to 0.235 volt. They have given value of E naught cell. It is found to be 0.235 volt. See here, for each and every reaction, so we have to calculate or we have to see carefully, that is the value of N. We have to find in this equation that is nothing but value of n. So by the value of n we can calculate equilibrium constant for this reaction. So here 2 into Fe3 plus is converted into Fe2 plus. For one Fe3 plus ion, Fe3 plus is reduced to give Fe2 plus, means transfer of one electron. Here the two this type of ions are there, means 1 into 2 electrons are transferred. Here this is reduced 2 into I minus 1 iodide ion loses 1 electron, it is converted into I. As 2 iodide ions loses 2 electrons to give I2, means here the loss of electron is 2, gain of electron is 2, so n is equals to 2. Now I will give the answer. So promptly you have to solve the equation, then compare with the answer. Here the answer is must be Kc is equals to 9.25 into 10 to the power 7. This much answer should come, 9.25 into 10 to the power 7. Okay, so this is about the equilibrium constant from Nernst equation. How to calculate equilibrium constant from the Nernst equation. So here by this we can come to know that the equilibrium constant, it is very difficult to understand, it is very difficult to determine practically. So for that we have to perform a lot of chemical reactions, isn't it? So the difficult chemical term or chemical determination can be done just by using Nernst equation. So Nernst equation makes the equation to be simpler to calculate equilibrium constant. I hope this video is hopeful to you, all of you, and please like, share, comment and like, comment and share among your friends if you find this video is useful. Thank you so much for watching.